channel Unknown Physicist. So we are on the second video of our series Mastering MMP. So in my previous video I have done on basic formulas which is really helpful for doing any problems in any competitive exams. Do have a look at it. I'm giving the link in the description box as well as in the iCards. Do check it. If you are a new visitor to this channel, in this channel I do make videos on different concepts of physics with easy tricks, and I do solve our problems for your better understanding. So if you feel this video is going to help you, don't forget to share it with your friends and give a thumbs up sign for it. So let's get started. Today we are going to see about matrices, which is linear algebra. So let's get into the video. Okay. I'm not going to do very much basic, but I'm going to give you clear idea about what are the different types of matrices in this video. So what is matrix? So first of all, matrix is nothing but transforming one vector in a vector space to another vector in a vector space. So that is what matrix means. So I will do some of the basics. So let me have two matrices A and B. If I'm going to multiply, then their product would be AB. So which you represent as A is equal to Aij into M cross N. So where M represents rows and N represents columns. And B is equal to Bjk into N cross P. So what would be my product? So AB will be equal to C, something C. So C can be represented as C into IK into M cross P, right? So this is what you get in the multiplication of matrix, right? So here in this video, I'm going to say about the types of matrix. There are different types of matrix. Please do not skip the video as I'm going to discuss the different types of matrix. All these will be helpful for you in finding eigenvalues. So I'm going to share a lot of tricks for eigenvalues. So don't skip these parts. So let us see what are the different types of matrix. First is based on the order. Based on the order. So under this we have four. First is rectangular matrix. First is rectangular matrix. So here the rectangular matrix, here the condition is your M is not equal to N. So your matrix should be something 0, 1, 3, 2, 0, 4. So this is a rectangular matrix. Next is square matrix. So it is square matrix where M is equal to N. So something like this, 1, 1, 2, 2. So here it is 2 cross 2, right? Next is row matrix. Next is row matrix. So here your M is equal to 1. So you will be having something 1, 1, 1, something of this type. Next is column matrix. Column matrix. So here your N is equal to 1. So it would be 1, 1, 1, 1, something like this, right? So these are the four different matrix based on your order. First is rectangular, square matrix, row matrix, and column matrix. Be clear with all this. Next is triangular matrix. So triangular matrix. So again in triangular matrix you have two different. One is upper triangular, other is lower triangle. Upper triangular, other is lower triangle. So in upper triangular you have, I will give you an idea how it is. A, B, E, 0, B, F, 0, 0, C, right? So this is how an upper triangular matrix. So if you have something like this, then it is an upper triangular matrix. So here it is A, I, J will be equal to 0 and I is greater than F, right? And then here lower triangular it is A, 0, 0, D, B, 0, E, F, C, right? So this is a lower triangular matrix. So here your Aij will be equal to 0 if your I is less than J. Okay, so combining these two, combining an upper triangular and lower triangular matrix, you have something called diagonal matrix. Diagonal matrix. So how it looks is A 0 0 0 B 0 0, 0, C. So this is how one diagonal matrix looks. So here your Aij will be equal to 0 and your I is not equal to j, right? So these are the three different types of triangular matrix. Next is scalar matrix. Scalar matrix. So here it is. This is how it looks: 0, 0, 0, A, 0, 0, 0, A. So this is an example for scalar matrix. I can represent it as Aij is equal to constant, when your I is equal to j, and then it is 0 when your I is not equal to 0, when your I is not equal to 0. Next is identity matrix. So here I can write the condition as Aij is equal to 1 if your I is equal to j. It is 0 if your I is not equal to j, right? Okay. So how does an identity matrix looks? It looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. So the diagonal elements are identity. So this is an identity matrix. So next is, okay, next we are going to see about transpose of a matrix. Next we are going to see about transpose of a matrix. So what does transpose means? So your rows are converted into columns and your columns are converted into rows. Columns are converted into rows. So for example, if my A is equal to Aij into n, then my A transpose would be Aji into n into m. So this is how. So let me give an example. For example, if my A is D A B C D E F G H I. So this is how I generally represent matrix. So then what would my A transpose? So all your elements are getting interchanged. So first it would be A G H D B I E F C. So this is what my A transpose looks. Still, if you want a clear example, I will write how it has. So if I have A11, A12, A13 and A21, A22, A23 and then A31, A32, A33. So these gets transposed. So then it would be A11. Next it has to interchange. So it becomes A21. Next it is A31. Next it is A12, A22, A32 and last it is A13, A23 and then A33. So now I think you would have get a clear idea how this transpose becomes. So you must be very clear with the transpose all these things because it is very much frequently asked in all your problems, right? So next we are going to see about conjugate of a matrix. Conjugate of a matrix. So what do you mean by conjugate? So let me take a matrix A is equal to A, B, C, D, E, F, G, H, I, right? So conjugate means your A star, your whole transpose. So first let me write what is A star. So A star is nothing but A star, D star, E star, G star, B star, F star, H star, I star and C star. So this is my A star. Now I have to do A star transpose. A star transpose. So which should be A star, G star, H star. Next is D star, B star and then I star. And then next is E star, F star and C star. So this is my A star transpose, right? So to be clear, conjugate of a matrix is represented by A dagger, which will be equal to A star the transpose. So if they are asking me to find a conjugate, You have to do A star and then check the transpose, right? Hope you got this. Symmetric matrix. Next is symmetric matrix. So what do you mean by symmetric matrix? So let me take A is equal to A, D, E, and then again D, E, F, B, F, C. So this is how a symmetric matrix looks. So if you are looking at the lower triangle and upper triangle, your elements would be same. So if I am taking a transpose for this, so what would I get? I would get the same. So A, D, E, and then D, B, F, E, F, C. So if your lower triangle and your upper triangle matrix are same, elements are same, then your A is equal to A transpose. So this is what meant by symmetric matrix. So in the symmetric matrix, they will ask a question, how many independent elements are there? That is the number of independent elements. Number of independent elements. So you have a formula for this, which is n into n plus 1 by 2. So here n, here it is 3. So 3 into 3 plus 1 by 2. So which is 12 by 2. So totally 6. So what are these 6 elements? So these 6 are 3 diagonal elements, 3 diagonal elements and 3 off diagonal elements. So apart from the diagonal, there are 3 independent elements. So this is an important thing which you have to remember. Sometimes in GATE, those kind of exams, they used to ask these type of questions, right? So this is all about symmetric matrix. Next is skew matrix. Skew matrix. So what is a skew matrix? It is kind of same as symmetric, but here your A transpose is equal to minus A. So for example, let my how it will look is A is equal to 0, D, E, F, minus D, 0, minus E, minus F, 0. Okay. Sometimes the skew matrix is also called as antisymmetric matrix. So it is just opposite of symmetric. So it is antisymmetric matrix, right? So here again they can ask a question, number of independent elements. So number of independent elements, which would be, again your n is, the formula is n into n minus 1 by 2. So here n is 3 over here. So which will be equal to 3 into 3 minus 1 by 2. So finally you have 3 as your answer. So the number of independent elements in an antisymmetric or a skew matrix is 3. Again, this is an important question which they can ask you. Orthogonal matrix. Orthogonal matrix. So what is an orthogonal matrix? So if A transpose into A is equal to I, then I can write A transpose as A inverse. So this is an orthogonal matrix. You have few points which you have to remember here. So determinant of an orthogonal matrix. What is determinant? I will discuss in my next video. Determinant of an orthogonal matrix. Determinant of an orthogonal matrix is either plus 1 or minus 1. So which we will see in determinants. Determinant of an orthogonal matrix is always plus 1 or minus 1. And then rows and columns of an orthogonal matrix. Rows and columns of an orthogonal matrix are orthonormalized or orthonormalized. Okay, or orthonormalized. Next is Hermitian matrix. Hermitian, which you have heard in your quantum. Hermitian matrix. So what is Hermitian matrix? You have another name. Hermitian matrix is nothing but A star transpose is equal to A. So that is nothing but A conjugate is equal to A. So this is what we called as Hermitian matrix. There is one more thing which is AntiHermitian. AntiHermitian matrix. Anti-Hermitian matrix. So which is your A conjugate is equal to minus A. A conjugate is equal to minus A. Next, last is unitary matrix. Last is unitary matrix. So in this unitary matrix, your A conjugate into A is equal to I. So your A conjugate will be equal to A inverse. Right? So this is unitary matrix. And then again here, your determinant actually it is a unit modulus. Determinant, it is unit modulus. What is unit modulus means? It is 1 minus 1 or else I minus I. So your determinant values are these. Again, we will see all these in our next video, which is all about determinants and determinant properties. And one more thing, even in your unitary matrix, all the rows and columns are orthonormalized or orthonormalized, right? So this is all about the different types of matrix. Once again, I'm repeating over here. You must be very clear with what type of matrix what it is, because all these we will see in eigenvalues, and I have a lot of tricks over there to share with you people. So still then keep reading what are the different types of matrix. If you feel this video has added any value to your preparation, don't forget to share it with your friends. So still then everyone keep practicing, stay safe, stay home. Bye bye everyone. Have a nice day.